Assalamu alaikum dear students. Let's continue with the solution of question bank of the chapter 1 units and measurements. In the last lecture we had discussed MCQs for the chapter. Now next we have very short answer types of questions VSA, where this session contains 1 mark each. Each question would be there for 1 mark only. First question is, define fundamental quantities and units. As the question is there for 1 mark only, so simply you have to just write down the definition. The physical quantities which do not depend on any other physical quantities for their measurements are known as fundamental quantities, and the units used to measure the fundamental quantities are called as fundamental units. This much you have to write down the answer for this question, and it is given on the page number 1 in the textbook. Second question is, define derived quantities and units. The answer for this question is given on page number 1 in the textbook. Students are supposed to write the answer like, the physical quantities which depend on some or all of the 7 fundamental quantities and can be expressed in terms of these quantities. So these quantities are called as derived quantities, and their units which can be expressed in terms of the fundamental units are called as derived units. Next question is, define dimensions of a physical quantity. So for the definition, here it is given on the page number 6. The dimensions of a physical quantity are the powers to which the concerned fundamental units must be raised in order to obtain the unit of the given physical quantity. Only this much definition you have to write for 1 mark. Then next question is, state the uses of dimensional analysis. As we had studied, there are 3 uses given, and only the uses you have to write. There is no need for any explanation. So on the page number 7 in the textbook, uses of dimensional analysis is given. So here you have to write down just the given 3 uses there. The answer would be, number 1, to check the correctness of the physical equations. Number 2, to establish the relationship between related physical quantities. Number 3, to find the conversion factor between the units of the same physical quantity in 2 different system of units. So this much you have to write the answer for this question. Then next, question number 5, state the dimension of density and area. Here you have to just write down the dimensional formula for density and dimensional formula for the area. As we know that the dimensional formula we have to write in a square bracket with minimum 3 fundamental units should be there, which is expressed in the dimensional analysis as L, M and T. Capital L represents the measurement of length, capital M represents the measurement of mass, and capital T represents the measurement of time. So in a square bracket with minimum L, M and T, and the power must be given to them, will gives the dimensional formula for the physical quantity. So here the dimension of density we have to write as, in square bracket, L raised to minus 3, M raised to 1, T raised to 0. Only this much you have to write for the dimensional formula of the density. And for the area we have to write in the square bracket L raised to 2, M raised to 0, T raised to 0. Only this much you have to write over here as the question is given, state the dimensions of the density and area. So directly you are supposed to write down the dimension of density and area. There is no need to write down the formula and its SI unit and then you are finally writing the dimensions, as the question over here is there for only 1 mark. So it is to be written just what is asked there, that much you have to write. State the dimensions of density and area. So the dimension of density is in square bracket L raised to minus 3 m raised to 1 t raised to 0. Dimension of area in square bracket L raised to 2 m raised to 0 t raised to 0. Only this much you have to write. Then next, question number 6, obtain the dimension of momentum. Now when the question would be asked in this way, then here we have to follow the method. First of all, we are supposed to write down the formula for the momentum and then we are going to determine the dimension of the momentum there. So as per the mathematical formula, momentum is nothing but the product of mass and velocity. Mass is measured in kilogram, velocity is measured in meter per second. So in the numerator only, the unit of the momentum would become kilogram meter second raised to minus 1, and hence the powers which over here is obtained by the SI unit, we are writing the dimension as kilogram has the power 1, meter has the power 1 and second has a power minus 1. So we are supposed to write down the answer. After that, the dimension of the momentum in square bracket, we have to write L raised to 1, m raised to 1 and t raised to minus 1. So when the question would be asked, obtain the dimension of momentum or of any physical quantity, so you have to first of all write down the formula, then you are supposed to write down the SI units in the numerator only and then write down the final dimension. And if the question would be there, state the dimension of any physical quantity, so directly you have to write down the dimension of that physical quantity there. The next question is, what is the order of magnitude of charge on electron? The answer for this question you have to write. The order of magnitude of charge on electron is minus 19. As it is 1 mark question, so simply you have to write down the answer, and also you can give it solution like as charge of electron is 1.6 into 10 raised to minus 19 coulomb. When we are determining the order of magnitude, so here we are supposed to write in this format like A into 10 raised to n, where A is to be written, the number is there in between 0.5 to 5. So here the value is given as A into 10 raised to n and this A is in between 0.5 to 5, hence n represents the order of magnitude there. So here the value of n we are getting as minus 19. So we have to write down the answer, order of magnitude of charge of electron is minus 19. Simply you can write down directly the answer like this, or you can give the entire solution also. The next question we are having, determine the significant figures of radius of earth. As you can see, the radius of earth r is given here as 6400 kilometer there. So first of all, here we have to write the value, the unit is given as kilometer, you have to convert it into meter and write down in the format as A into 10 raised to n, where A should be in between 0.5 to 5. As you can see, there is only 2 non-zero digits, so simply directly you can write down the significant figures are 2, or you can give it solution as r is equal to 6400 kilometer. So it is to be converting into meter by multiplying 10 raised to 3, and hence when we are shifting the decimal point to make the number in between 0.5 to 5, so it becomes 0.64 into 10 raised to 7 meter. So here the number A, which gives the significant figures, and hence here the two significant digits are present, that's why we can give our final answer as significant figures are 2. So, here we had discussed the very short answer type of questions VSA which carry 1 mark each. After that, now we are having short answer types of questions SA1, where each question would be there for 2 marks. The first question is, define derived quantity and state its example. Here we have to just write down the definition of the derived quantity, that is the physical quantity which depends on one or more fundamental quantities are called as derived quantity, and its unit which depends on one or more fundamental unit is called as derived unit. Example we can give like velocity, then area, acceleration, force, etc. are the examples of the derived quantity. Now the next question, check whether the equation is dimensionally correct. V square is equal to u square plus 2as square. Now to check the given equation is dimensionally correct or not, here we have to write down the dimensions of all the terms involved in the formula. So here we have to write down the dimension of v square, dimension of u square and dimension of as square. S2 is a number, it is dimensionless quantity. After determining the dimension of v square, u square and as square, or simply you can write as dimension of 2as square also, we have to see the dimension of all these 3 terms are same or not. If all the terms having the same dimension, then we have to write the given equation is dimensionally correct, or if any one term has different dimension, then we can conclude the given equation is dimensionally incorrect. So here as v square is nothing but the velocity, and velocity has the dimension L1 m0 t minus 1. So v square is there, so the dimension of v square would be L2 m0 t minus 2. Then u is the initial velocity and here the term is u square, so it would be the same dimension, that is L2 m0 t minus 2. Then for 2as square, as acceleration has a dimension that is L1 m0 t minus 2 into s square, where this s represents the displacement and hence the dimension of the displacement square is there, its dimension would be L2. So 2as square would have the dimension that is L3 m0 t minus 2. So dimension of v square and u square is same, but the dimension of 2as square is different. So we can say that the given equation is dimensionally incorrect. Now the third question is, state the conventions for the use of SI units. Here the question is given for 2 marks. So any 4 conventions you are supposed to write, and in the textbook on page number 2 the conventions for the use of the SI units are given. 8 points are there, any 4 points you are supposed to write there. Then next question number 4, state the rules for determining significant figures. So here also, as the question is there for 2 marks, so any 4 points you are supposed to write. On the page number 12 in the textbook, Rules for determining significant figures are given. 4 points are there. You have to write all 4 points there. Then next question, number 5. Check whether the equation is dimensionally correct. S is equal to ut plus half at square, where S is the displacement, u is the initial velocity of the body, a is the acceleration and t is the time. So here we have to check the dimension of all the terms involved in the formula is same or not. We are having 3 terms, S, ut and half at square. As already we had done during the explanation, the dimension of S here we are supposed to write as L1 M0 T0, as S represents the displacement. The dimension of ut, where u is the initial velocity and t is the time. The velocity has the dimension L1 M0 t minus 1 and t has the dimension t raised to 1. So, when we will solve it, we are getting L1 M0 T0. Then for half at square, the number half is not accountable here. We have to see the dimension of at square there. So, a is the acceleration whose dimension is L1 M0 t minus 2 and t square has the dimension t2. When we will solve it, we are getting the dimension as L1 M0 T0 there. So, the dimension of each term we are getting as L1 M0 T0. So, here the dimensions of each term are same and hence we can say that the equation is dimensionally correct. Equation S is equal to ut plus half at square is dimensionally correct. Now, the next question we have number 6. Check whether the equation is dimensionally correct. V is equal to u plus at, where V is the final velocity, u is initial velocity, a is acceleration and t is time. So, here again we have to check the dimension of each term involved in the formula is same or not. One term is V, another term is u and third term is at. As V and u is the final and initial velocity, it has the same dimension, that is L1 M0 t minus 1. Then at, we have to determine the dimension of it. A is the acceleration whose dimension is L1 M0 t minus 2 into t. So, the dimension of t is t raised to 1. When we are solving it, we are getting L1 M0 t minus 1. So, here we are getting L1 M0 t minus 1 is the dimension which is same for all the terms involved in the formula. Hence, we can write the given equation V is equal to u plus at is dimensionally correct. After that, the next question is number 7. Write down the number of significant figures in the following. Number 1, 0.003 meter square. Number 2, 0.1250 gram per centimeter square. Number 3, 6.4 into 10 raised to 6 meter. Number 4, 9.1 into 10 raised to minus 31 kilogram. Now, here to determine the significant figures, we have to follow the rules. As in the given question 0.003 meter square, the non-zero digit is 3 and there is only one non-zero digit. After that, there is no digit is present. So, here we can say that the significant figure is 1. In second example, 0.1250 gram per centimeter square, from 1 the non-zero digit starts and after that 2, 5 and 0. These digits are also considered as significant figures, hence 1, 6250. These 4 digits are to be taken as significant figures, hence we have to write significant figures are 4. Then in the next question, 6.4 into 10 raised to 6 meter. In this format, we have to just look at the number a as it is given in the format a into 10 raised to n. So, for the a, here we have to follow the rules. 6 and 4, 2 digits are present, which is significance over here. So, the significant figures are 2. Then in next example, 9.1 into 10 raised to minus 31 kilogram. Here 9 and 1, 2 significant digits are there, hence significant figures are 2. Now, if it will be asked to you 1.6 into 10 raised to minus 19 coulomb, for this what would be the significant figures? So, here also we have to follow the same rule. 1 and 6, 2 significant digits are present, hence significant figures are 2. So, in this way you are supposed to write down the answer. Then the next question is number 8. The nuclear radius has a dependence on the mass number A, as r is equal to 1.3 into 10 raised to minus 16 a raised to 1 upon 3 meter. For a nucleus of mass number A is equal to 125, obtain the order of magnitude of r expressed in meter. Here we have to determine the order of magnitude of the nuclear radius r, which should be expressed in meter. Let us have the solution. As r is given 1.3 into 10 raised to minus 16 a raised to 1 upon 3 and value of a is given 125. So, here we have to substitute the value of a as 125 and cube root of 125 is 5. So, let us simplify this equation, and the multiplication we are getting as 6.5 into 10 raised to minus 16 meter. Now, after getting this value, we have to convert the number in a format a into 10 raised to n, where value of a should be in between 0.5 to 5. As here a is 6.5, its range is greater than 5. So, that is why here we have to shift the decimal point, and as we are shifting the decimal point, so here 10 raised to 1 will be come in the with the multiplication there. So, 6.5 is nothing but 0.65 into 10 raised to 1 into 10 raised to minus 16 we are writing as it is. When we are solving it, we are getting it as 0.65 into 10 raised to minus 15 meter. Now, this 0.65, which is a number a, comes in a range between 0.5 to 5. Hence, the power of 10, which is to be considered as the order of magnitude for the nuclear radius r. Hence, we can write the order of magnitude of r is minus 15. The power of 10 we are getting here as minus 15. So, the order of magnitude we are supposed to write as minus 15. As well as we can write the same as this 10 raised to the power with its unit. It also expresses the order of magnitude. So, here we can write the order of magnitude of r is 10 raised to minus 15 meter. So, here we have discussed very short answer types of questions VSA for 1 mark each, as well as short answer types of question, that is SA1 for 2 marks each. The question bank with its solution for the chapter 1 units and measurements will be continue next time in the next lecture. Thank you.